Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 6, 6.3, and Integration by Substitution. Integration by substitution changes the variable in an integration in order to make the integration easier to do, and it uses a version of the chain rule. What we'll do is we'll have a look at an example. I'll take you through the first half of it, and then I'll ask you to complete it yourself. So we've got an integral which would be tricky to do by normal means, but what we're going to do is we'll carry out this integration using the substitution u equals 3x minus 2. And the reason why they've chosen u equals 3x minus 2 is because of this bracket. Changing 3x minus 2 to u makes things a lot easier. What we need to do is we need to substitute in for wherever it says x, that's going to have to change to u or some function of u. And also dx needs to change. So we'll be integrating a function of u, and we'll need to integrate that with respect to u. So both of these things are going to have to change. First of all, going back to the original substitution, u equals 3x minus 2. If I rearrange that, then I get x equals u over 3 plus 2 over 3. That'll allow me to substitute in here. X is equal to that. So substituting in, x plus 1 becomes u over 3 plus 2 over 3 plus 1. And as we said, the 3x minus 2 is just equal to u. So that becomes u to the power of 7. Now we've still got the dx. That also needs to change. And the way we change that is by going back to the original substitution and differentiating it. So we find du by dx, and that just equals 3. And then using the chain rule, we're allowed to rewrite that as du equals 3dx, or rewriting that as dx is equal to 1/3 du. And that is what we substitute in here. So instead of writing dx, we get 1/3 du. So the whole thing now simplifies to this. This bracket, when I do 2/3 plus 1, gives me u over 3 plus 5/3. Still got the u to the 7 there. And the dx has changed to 1/3 du. Now I'll let you have a go at finishing the question from here onwards. This is just a standard integration. We've got a third here. We've also got another third here in this first bracket. So when I do it, I'll take out 1/9 just to make things look more straightforwards, and then integrate it in the normal way. Once you get the answer, the last thing you need to do is undo the substitution. So wherever we've written u in the answer, you'll need to change that back to the original letter, which is x. So u will change to 3x minus 2. Okay, I'll let you have a go at seeing if you can make sense of all of that yourself. So pause the video, have a go at finishing the question, and then come back to me when you're ready. Okay, let's have a look. So as I said, I've taken out 1/3 from here, and I've also taken out another 1/3 from this first bracket, which gives me 1/9 outside of the integration. And this first bracket just becomes u plus 5. Multiplying out those brackets gives me u to the 8 plus 5u to the 7. That's where we've got so far. And then integrating that gives me 1/9 u to the power of 9 plus 5/8 u to the power of 8. I'll multiply by the 1/9, and that gives me 1 over 81 times this plus this. And then the final thing that I need to do, and this is always the case whenever you use a substitution, the last thing you need to do is undo the substitution and return back to the original variable. Well, u is equal to 3x minus 2, so we just substitute in u equals 3x minus 2 in this, and that gives us the final answer. Okay, example 2. Find what looks like a quite complicated integral by using the substitution u equals cos x. Now again, I'll take you through the first half of this question, because something happens in this question which frequently happens in this type of question. So there's no problem with cos x. Cos x is u. We're going to be able to substitute in for that. Differentiating that gives us du by dx equals minus sine x, and rearranging that gives us dx is minus 1 over sine x du. So we can substitute in for the cos x here. We can substitute in for the dx. There is still an issue about what we do about the sine x. But as is frequently the case in this type of question, it turns out you don't need to worry about the sine x. So substituting in Cos x is equal to u, so I've substituted in cos x equals u there. And dx is equal to minus 1 over sine x times by du. So I've substituted that in there. And then at this point, you notice that you've got sine x on the top, you've got sine x on the bottom, you've got sine x divided by sine x. They cancel with each other. So the sine x's, they just sort themselves out. And the whole thing simplifies to the integral of minus 3u plus 1 to the half du. Then you carry on as normal. Now, it's a slightly confusing integration, but I'll let you have a go at doing it. So integrate that function with respect to u. Once you've done that, then substitute back in u equals cos x to get the final answer. But have a go yourself, pause the video, come back to me when you're ready. Okay, let's have a look. Now, if I integrate that, I'll get minus 2 nines, 3u plus 1, the power goes up by 1 to 3 over 2. And as is always the case with this sort of integration, you should quickly differentiate this answer to make sure it does go back to the question. And when you differentiate it, you have to times by the 3 over 2, the power goes down by 1. Using the chain rule, you also have to times by 3. But that is what you should get for the integration. And then the final thing is substituting in u equals cos x, and that gives us the final answer. Okay, example 3. The only thing that's been added to this example is we now have limits. And that does just add one extra thing that you need to take care of. So we're doing this integration between x equals 1 and x equals 3, using the substitution u equals 2 minus x. And again, that substitution's been used because this bracket here is 2 minus x. And that's what makes the thing simpler. Rearranging that gives me x equals 2 minus u, which is what I'll substitute in here for x. And differentiating the original substitution gives me du by dx is minus 1. Rearranging that gives me dx is equal to minus du. Now, the extra thing we need to be careful of on this question is these limits. We're going to do an integration in terms of u, with respect to u. That means these limits also have to be changed to u equals something and u equals something else. That is easy to do because the original substitution tells us what u equals in terms of x. U is 2 minus x. So changing the variable for the limits, the upper limit when x equals 3, u is 2 minus 3, which is minus 1. The lower limit when x equals 1, u equals 2 minus 1, which is 1. Now we can change everything in here. So just have a look at how each individual thing has changed. The limits have changed from x equals 1 to u equals 1, x equals 3 to u equals minus 1. The x here has changed to 2 minus u. 2 minus x here has changed to u. And last of all, the dx has changed to minus du. Now, the next thing I will do is I'll take this minus outside of the integration, makes things a little bit easier. So the minus with the du I've taken out to here. This bracket I've multiplied out to get 7 minus 3u. I've still got u to the 4. Now I'll let you have a go at finishing the question. So you'll need to multiply out these brackets, carry out the integration as normal, put in the limits, and this time you will just get the right answer straight away. You don't need to undo the substitution. Okay, I'll let you have a go at doing all of that yourself. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look at this together. Apologies if the sound of the rain falling on the roof is very loud. So that's where we've got so far. Multiplying out the brackets will give me that. Carrying out the integration will give me that. Now I've got to put in the two limits. That should be u equals minus 1 and u equals plus 1. Putting in minus 1 gives me that. Putting in plus 1 gives me that. That gives me minus 14 over 5, and I pop all that in the calculator. And that simplifies to 14 over 5. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 77 and have a go at exercise 6C. Thank you very much for listening, and cheerio.